Hi, folks. This is Bill from AT Makers. I had a quick update, and I want to make sure this is off so you guys don't have to hear me twice. I am watching on Facebook. If you have any questions, I'll type in hi. I don't always see the comments. I'm not entirely sure what's up with that. But if you're here and you're watching, type in say hi. I can even, I think, pull people in if you'd like to. So I want to update you on the PCB project. So if you guys were on here for the review we had a week or two ago, I'm not sure. We've made some progress. It's kind of cool, and I thought I would share a couple things that are worth noting. Big one being how the PCB process is coming, and I'll give you a little more information about that just to catch people up on what we're talking about. We're talking about a PCB, not PCP, a PCB version of the switch router that we made for Jim Lubin. So this is the 3D model of it that we're talking about, not the gray part here, just the colored parts. So this is one PCB that would be populated with 5 relays, sets of screw down terminals or solder points for you to connect your wires, a current sensor, and the ability to pop on a feather, an Adafruit feather, to control Wi-Fi, Bluetooth, things like that. This would be a real kind of game changer in the complexity of the things that we could make. So we did a design review, and I want to thank folks for tuning into that. We got some great feedback. We found a couple of problems that other folks found just by getting another set of eyes on it, and that was great. I'm going to close Fusion so it can stop eating all my memory, and go into Eagle. So this is a program that we use for making printed circuit boards, and I have actually never gone all the way through this process. Which is kind of neat that you can start something like this and really have no formal training on the PCB process. Watch some YouTube videos, get some advice from people like the folks at Adafruit on how to do certain things, and you can make a PCB. And it's kind of crazy. This, if you look carefully, this is a relatively complicated two-sided PCB. I got to give credit to John Jordan, who did the initial and most of the layout of this. We worked on some final stuff together. But again, he did most of this with no detailed training on this kind of stuff. We both are feeling our way through this. So we got to the point in this where we wanted to get this made. We talked about making these ourselves. Neither one of us have a lot of surface mount soldering experience, and so we decided to go ahead and have these assembled by a manufacturer. So we went and we looked at Macrofab, we looked at Oshpark and some other things like that, and I coincidentally right around the same time I got a request from a company called PCBWay to ask if I would be a judge for a PCB contest that they have going on starting in June. And basically, they wanted to add a contest for a PCB solution, a PCB-based solution in assistive technology, and if I would be a judge for that. And I have told them yes, but I wanted to have gone through something with them. I wanted to have gone through pricing out a board, getting it delivered, having it assembled, and I happen to be doing this, so I decided let's try and push this through the PCBWay.com tool. Now, they are a 100% offshore company. They're a China-based company. And I went ahead and went through the process of sending them the files they would need to print the PDF file, or PDF, to print the PCB board. Also to have enough information to be able to populate it and get it back. So I want to show you kind of how that worked. And then something happened this 2 days ago, which is kind of shocking, that I really want to walk through what we did about the tester because it's worth you guys seeing. So here's the PCB board that we were talking about making. It has, as I said, 5 different relays that need to be soldered on, 2 relay drivers, one port expander, and a current sensor. And then a lot of like passives and buttons and LEDs and other things that are necessary to make this work. We're pretty sure about the design at this point. It's been checked several times. And we wanted to do just a small run, get 10 boards, see how they work. So I went and I followed their instructions at PCBWay. And I uploaded the what's called the Gerber files, the instructions for how to build this from Eagle. So Eagle actually has a tool right here where you can go in and say, no, I guess I have to, there you go, where you can actually tell it, export all the steps that they will need to manufacture it. So here's the top copper, the bottom copper, the outline that they're going to cut, where the solder mask goes, top and bottom, where the paste goes, where the silk screen goes, that's the text that you put on it. And so it basically generates out these files, which you then upload to PCBWay. And I uploaded them, and I asked for a quote. And basically, the quote was whether I wanted 10 or 50, the difference, the total cost was somewhere between $40 and $60, $40 and $70. So I said, well, okay, let's price 50 since there's effectively no additional cost to getting twice as many. Let's get 50. That's where it started going up. I think that's probably how many they could fit in one batch or something like that. So I said, okay, let's get 50 boards. The total cost for 50 boards is $62 delivered, which was kind of shocking, right? Delivered from China. And I wasn't sure about that when I was looking at it because it seemed kind of crazy. And this might come across as an ad for PCBWay. I've never done business with them yet. This is the first time I'm doing it. I'm just telling you that this is remarkable as far as where we are as a technology and a society. So this would take $62 total to get 50 boards made. And then the labor for assembling the boards would be another $88. So total for the board and the assembly would be $150, not counting the components that go on the board, so the relays and the other stuff. So I sent them what's called a bill of materials, a BOM. They sent me back some questions, and we're going back and forth on exactly which part number, can they do some substitutions. And we were talking with, I was talking to John about, if we're going to do this many, if we're going to do 20 or 50 or however many, we need to be able to test this. It's not going to be like making one. We're going to make a bunch. We need to be able to test this, and we really should automate the test. And I actually was thinking about a video that Adafruit made, Adafruit tester, where Lemore-Fried actually walks through how they do their testing, right? So I'll mute this so you don't have to hear her. But she walks through exactly how she makes a tester, how she uses pogo pins to be able to push the thing down and test it in an automated way to make sure that it's accurate. And she's very detailed, and I gotta thank her for this. But I kind of decided, well, what would it take to do that for this board? What would I need to do to make an automated tester for these boards? And should I think about it while I'm ordering things from China? So I thought, okay, well, what would it take? So I followed her process and just kind of explained the process. She takes the current layout of the board, removes all the components so that she only has the contact points, and then she makes something that uses a separate component, a Teensy, or in my case a Teensy, another board to test this one. So I followed her process, and you can see so this was 2 nights ago. What's impressive about this is the speed. So on the first time I worked on this, I don't know if it's in the properties on here, maybe not. So I started working on this, today is Thursday, so really late Monday night. Okay, so really late Monday night, I started thinking, hey, I should make an automated tester. I took this board and I did exactly what she said. I removed all the traces from it, so that all that was left was where the solder points were going to be, where the headers were going to be for the feather, where the headers were going to be for the terminal jacks. And then I added space over here for a Teensy. A Teensy is a separate board. They're about $20. And basically, it's another microcontroller. In this case, the reason I went with a Teensy is it's got literally 40 different I/O pins. So it's got 40 different pins that you can use to read and sorry, Brady just popped up. Profile only has 2 holes. It technically has 4 holes, 2 of which are plated. So we'll talk through that, Brady. I'll be happy to go through that. So I started with basically an empty board, and I added a space for a test board, okay? And I then went ahead and I decided, okay, every one of these pins over here, let me make this bigger so you can see. Sorry, wrong one. This one. So every single pin over here needs to come over to an I/O pin so that I can say, all right, I think that this relay should be closed. Therefore, these two should be connected. And I can test that. So I basically went through, and in about an hour, about 2 hours total, I added connections between all of the pins that we're talking about on the controller and all of the solder points that are going to be on the board. So this will let me write software that says, okay, test relay 1, test relay 2, test relay 3, relay 4, relay 5, test the current sensor, make sure that the leftover I/O pins up here are working, and when you hit this button down here, this square thing at the bottom is a button. When you hit that, it will run the tests and either give you back a red or a green light as to whether or not it succeeded. Okay? So I did this that night, and I actually think it turned out pretty good. It was nice to be able to do that as quickly as I did. Turn those vias on so you can see them. And I thought, okay, well, what would it take? This doesn't have any components that aren't through-hole components, right? They're all things that I can easily solder onto them. I can put the headers on the Teensy. I can pop that in it. I can put on the 2 resistors and the 2 LEDs and the button. Those are easy. So I don't need anybody at China or a PCBWay or Macrofab to assemble this. I just need a PCB board so that I don't have to do all of that wiring, right? What is it going to take? And this is what's so darn impressive about what happened next. I took this and I exported the Gerber files, right? The files to send to PCBWay. And I went into PCBWay, okay? And this is kind of nuts. So if you look, I placed an order. I uploaded those Gerber files and hit yes. Gave them my credit card and everything at 9:42 a.m. their time on the 29th. So this is 2 days ago. Okay, 2 days ago, I said go. Okay. So they started manufacturing. They completed manufacturing 5 hours later, right? Or let's see, I guess they completed about 10 hours later. And the next day, on the 30th, 1 day after I placed that order, they shipped that product. And at this point, right? So at this point, if I look at the logistics here, right? View logistics. It keeps popping up a separate window, sorry. So if you look carefully at this thing left, it was picked up. Here's the tracking at DHL. So it was packed up in Shenzhen and made it through Hong Kong within 12 hours. And a day later, it's in Cincinnati, having been printed. and it's going to be here tomorrow. I got 10 boards made, and I paid a total of $23 with shipping, and it's going to be here in 3 days. And I think that's a little bit nuts, right? I don't think I'm overstating to think that I was shocking that in 3 days I could get a double-sided board made, shipped from China, and in my pocket for $23, for $2.30 each. That's crazy. So I am looking forward to getting this tomorrow and seeing if this works. I mean, it's one of those things that kind of changes your view of whether we should be doing this much soldering, right? It is. I recognize its wage arbitrage. I recognize the downsides of offshoring. I do get it, but this is kind of shocking that you can go from a thought in your head to a printed circuit board in 3 days for $23. That's, to me, that is absolutely worth sharing with the group, because it kind of opens things up. If you want to make something that's AT specific with a bunch of points that people can touch and they're all capacitive touch, and you think, oh, I'd have to get a custom board made. So what, right? Even if it's a big board, you're going to be talking about $40 instead of $60 to get 10 of them. This to me is eye-opening. So I thought I would share it with you. I am amazed that it is sitting in Cincinnati, printed 2 days later, and it will be here. Or there's the tracking one. It will be here tomorrow by end of day, which is crazy. So I was I think that's kind of cool. So the bigger thing is I need to finish the BOM, get them the actual part numbers for a couple things. So this one is waiting on me. So this under review one is not their fault that it is not moving. They sent me back a list of things that were in the bill of materials that were ambiguous. So two parts. They found 2 different parts with the same number. I need to tell them which one I need. To be honest, I don't know which one I need. And I'll talk with John about that. And then a couple of things on there I don't want them to place. So I don't want them to put the headers on. I don't want them to put the screw down terminals on. And I just need to mark them do not populate, and they'll remove that from the list. Their pricing was right what we found on DigiKey. So there's no markup on that. They might have gone to DigiKey. I don't know where they got their prices, but they were within a penny or two of all the prices that we found individually, which is great. And I really hope I have a great experience with this, not just because I've agreed to be a judge for them, and I would hate to be backing out of that. But it is interesting to see that this capability is available to people who aren't traditionally in the manufacturing space. All right, Brady's got a question. If any of the rest of you have questions, let me know. If you have questions later, then post them in the bottom. For the switchboard, they're just doing the surface mount or all the soldering. So they are going to do just the surface mount soldering. There are a couple things that they weren't clear they're not really things. All right, so Brady, let me show you. So if you look here, they were asking about, let me flip this over and show the back view. One sec. Okay. So if you look, these A1 and AT are actually cuttable traces, right? That determine the address of the I2C bus. So they were asking, because these are parts in Eagle, in order to get the placement correct, but they're not really parts. They're asking what these things are. And then these, we are not going to have them populate the screw down terminals. Mainly because we think some people will want to solder rather than use the screw terminals, and so we'll sell them separately. They're all through hole. It's easy for them to do. Similarly, we don't know whether people are going to want female or male headers on this, so we'll leave those unpopulated for all the headers. So really the only thing that we're having them populate, let's flip it. And I really wish there was one button that would do this, because I do the same thing over and over and over again. So looking at the front, you can't see. Sorry, one sec. There you go. So you didn't see that. Hold on, let me show you again. I still wish there's a way to flip this easier. All right, so on the bottom, we have these things that look like components. They look like things that would need to be placed, but they're actually just cuttable traces. So they were asking about those. They didn't understand them. And then on the front, which is here, on the front, what they're really going to place is going to be these. So this is a relay driver, the I2C port expander, the current sensor, a couple of capacitors, a couple of resistors, and the 5 relays. Oh, and the button and the LED. So the things they're not doing are going to be everything along the outside, and then the big headers here for the feather. So hopefully that will explain it. Their labor will probably come down a little bit from that 88 when we reduce the number of components that are on there. Not a lot, I don't think. I think most of that 88 is for the setup. The number of components probably doesn't change much on the labor. The cost of the components is really the issue there. So I hope you guys find this marginally interesting. I found it fascinating to see that's the pricing. That's nuts. It's going to change how what I think about when I'm making components, and whether or not it's worth my time. Certainly not worth my time to spend the amount of time I spent on Jim Lubin's board with all that wiring. The truth is, even if I stuck to through hole and made it bigger than it needs to be, because the whole reason we went to surface mount here is we wanted to keep it small enough to be a feather wing footprint. But even if I didn't do that, even if I kept exactly the layout I had on Jim Lubin's board and just didn't do the soldering myself, and did that in Eagle or KiCad or KiCad, however you say it, if I did that in a PCB design software and shipped it to PCBWay and got it back 3 days later for $20, I would have saved 10 hours of work. I'm worth more than $2 an hour. It's a crazy thought to think that that's where we are. So if anybody has thoughts on this, let me know. I will be looking forward to it later. And you guys all have a good, it's almost the weekend. I'm going to Atlanta this weekend. Going to see a couple of you fine folks up there. I'm also going to go see Hamilton, which is kind of cool. And today's my wife's birthday, so I need to take her out. And happy birthday. I don't know if she's watching. Probably not. Bye.